Right, so this lecture is going to be all about calculating truth tables, which, as I said, are good exam questions. The maybe the most fundamental yet interesting one is the following. So, show that P implies Q. Well, we've got the truth table for that. Is true if and only if not P or Q. Okay. Now, what this is asking you to do is calculate the truth table for this, write down this one, and check that they're the same. Okay, so we have 4 possibilities in total for P and Q, 2 for P, 2 for Q, as in true or false. So we're going to get 2 truth tables with 4 lines each, and then we just check that the end columns are the same. So P implies Q. Let's do that one first. So we're going to have P, we're going to have Q, we're going to have P implies Q. Fill these out in however way you would like. You want true, 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 false, false, true, false, false, but just make sure you get all the possibilities. And then the rule for B implies Q is that it is going to be true unless when you take P to be true and Q to be false. So if I promise you that P is true, then I have to promise you that Q is true or I'm lying. Okay, so true, true, there's nothing wrong there. True, false, that's the problem. False, true, false implies everything, remember, so that is that. Now let's do this one. And I want to do it slowly to illustrate the way that you build up more complex propositions, the truth values of them from the component parts. So I'm going to start with P, exactly the same, start with P and Q, and we'll take the same true, true, false, false, true, false, true, false. So we started the same, and now let's build this up. So we've got P. Now the thing to do next is the not P, right? And then we can treat that as one thing and compare it with Q. So we'll have a new column, not P. So for that we get false, false, true, true. And then we have to compare the truth values that we get from Q and not P. And this will be true whenever one of them at least is true. But if they're both false, then it will be false. Is one of these true? Yes. Is one of these true? No. Is one of these true? Yes. Is one of these true? Yes. Now you can compare this column with this column and you can see that they are the same, and so this is done. Right, I'm going to do one more example of a truth table. I'm going to go through the example that is in the notes. This is example 391, but I'll do it slowly so you can see how you build it up yourself. The good thing about 391 is that example 391, is that it has 3 different propositions. So if you have 3 different propositions involved, you have to consider all of the 2 times 2 times 2 possible ways of assigning truth values. So you're going to get 2 times 2 times 2 is 8 rows. So let's do that. we're going to have P, Q, and R. And I'll just remind myself at the top right what we're aiming to do here. We want to get the truth table. So this is the truth table for not P implies Q or R. Okay, so that's a V there. So not of P implies Q or R. You might think that this is a kind of so complex you would never say it in real life, but you will actually find that it's the sort of thing that you would do. Somebody may say to you that every time it's sunny, you either put a hat on or you go swimming. And you would say, no, it's not the case that every time it's sunny, I would put a hat on or go swimming. You know, there would be other times that I would maybe go to the park. I don't know, something like that. So even though this looks complicated, it will turn up in real life. Okay, so let's do it. We want to write down all the 8 possibilities, so you just have to find a way to get through them all. I'm going to do it this way. It's a bit like writing in binary, if you know how to do that. You just want to change this right one whenever you can, and to get a new thing. Otherwise you change this one to get a new thing. Right, so that's where we need to do it. And then yes, reset it to true afterwards. Okay, so those are the 8 possibilities. And we're going to build this thing up slowly. So we want Q or R to start with. Go bury yourself right in the middle of it first. Find the smallest thing to do and then build it upwards from there. So Q or R. Remember, to do this, all we have to do is to find one of these that's true. Yep, or we write false. So something is true, something is true, something is true, nothing is true, something is true, something is true, something is true, nothing is true. Okay, good. Now we need to do P implies this column. And we know that the only time that goes wrong is when something here is true, but there is false. Yeah. Otherwise it's true. We are not concerned about it unless this is true and this is false. So let's do that one. P implies Q or R. This is true and this is true, that's fine. Similarly, fine. Similarly, fine. But not here. True, false. So P does not imply Q or R. Otherwise, P is false, and false implies everything. So these are all true. And then for the very final column, you just need to reverse all the truth values that you've written down, because we're taking the not of it, the negation. So just flip them all. False, 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 true, false, 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 false. And that is the truth table for this statement. And it doesn't take too long to do. Final point. Let's have a look at this. Let's have a look at this right-hand column. You can spot there's only one time in all of the different possibilities where this is true, and that's when P is true, and Q is false, and R is false. And I've been using the word "and" because that is the logical connective which describes this behaviour. So from the truth table, we see that this complex statement here, so not of P implies Q or R, is actually the same thing. So it's true if and only if P is true and Q is false and R is false. Okay, now I said that, gave this example of, it's not the case that just because it's sunny I'm going to wear a hat or go swimming. If that is a reasonable example, then this one should be as well, if I say it in these terms. So it's sunny and I'm not going swimming and I'm not wearing a hat. Right? There are times when it's sunny and I'm not wearing a hat and I'm not going swimming. So yeah, it checks out. And you can, once you get used to these sorts of word games, you can, use them to express yourself in different ways, which can be very useful to make things clearer for people. Okay, that ends week 3.